NADI system stands for Network Analysis and Data Integration. It has a bunch of systems inside it. One of them is Graphical Information System, the GIS side, and then there is a domain-specific programming language with the task system. So normal workflow is you download your data, you pre-process it, use the GIS system to get your network, and then you use the network analysis with the domain-specific programming language, and then get your result, and you can post-process it. You can skip the GIS portion if you have your network, and you can simply write it in a text file, simply load it into the analysis, because GIS system will just extract that into a text format. So this is the NADI book. It has information about how the NADI syntax works, as well as different concepts, so you can go over it. You can learn about different segments of the NADI system. You can see the installation instruction, how to compile it, how to download it, and you can also look at examples running the GIS section. You can run it as a QGIS plugin, and then you can learn about the core concepts in the network analysis part, and then use them with a custom syntax. So this video kind of assumes you went through this, but I'll explain things in a simple manner. So this is the whole main UI for the NADI task system. You can open different segments here. For example, text editor looks like that. You can open a help menu which has all the functions listed here, so you can click through them and look at how to call that function, what argument it takes, and there are also some examples to see how you can use it, what the expected output is, and it also shows you the code, the Rust code that's internally used on that function. So you can copy this and then write your own function that does things slightly differently. Those might be useful for more complicated functions that use external libraries, so it might do things in a little bit different way than you want. So if you cannot customize it based on the function argument, you can just take this code, compile a new plugin, and load that function from that plugin. There is also a link to go to the NADI book that you can see here. You can also get it in a PDF format and then browse through the sections. It has the same concepts, so you can read through those, look at the examples, and then run it and see. So we will use this to kind of run some examples. So I will open it on this side, and I'll open an editor with network viewer and terminal. So by default it loads these things. You can also close things, rearrange them in a different way. I will open a terminal here and then split this into network. Okay, so for example, a network basically consists of different connections. So I'm loading here A goes to B, B goes to D, and C goes to D. So if I load it by running this line, it now shows the network by running this. So you can also look at the network attributes. So we have these attributes that are there by default, but you can kind of assign different attributes. So if I do node value equals to 90, then all of these would get value equals to 90 as a different attribute. So you can choose which node gets certain attribute based on some parameters. So if I do this value equal to 19, then only A that satisfies this condition, this one, got value as 19, everything else is still 90. So You can use conditional, and you can also use like some attributes that help you help visualize the network. So a little bit detail on here, like node color, line color, text color, and those things you can change. You can read this detail on which attribute can does what thing and what possible values are. So for example, if I do node text color is red, then it changes text color red on all of them. But if I change it to node color, like if I choose some node here specifically, then only those attribute of only those node will be changed. So there are a lot of things that you can change that you can like see from here, like different node shapes. So these are just the basics. So for the visual properties, so more concepts we can go. So one concept is attribute. As you can see, like each node has attributes. Network also has attribute. Right now it has nothing. So if I do network name equals to sample network, then I will get network attribute as a name, which is a string with sample network. So you can make different attributes here. You can have boolean value, you can have integer, you can have float, and you can have date value, date time value. All those things are supported. And this one shows the attributes. So if I look at this, it has an array with all these different type of values. Similarly, you can write a map with a equals to do this b c d. Okay, so now it is a table with different key with different values. So you can nest values with this. Most of them follow the TOML format, but you can look more detail into what attributes are supported in an attribute section. You can see it in this table. So if you want to try other concepts, there is the portion about expression. So expression is simple. So if you do 1 plus 2, it will result in 3, and so on. So it can contain a lot of values that you can run. You can use a conditional greater than 9 will evaluate to true, and you can also call functions. For example, sum 1 to 3 will result in 6. So these are the expressions. And as you can see right now, like every one of the tasks in a task system has to start with these 3 keywords that are network, environment, or node. So when you run a node system, it gives you multiple value when you try to get a value, and it sets multiple value when you try to set a value. So if I do 22, you can see it's changing value for all the nodes. So when you run a node function, it runs it for each one of the node, but when you run a network function, it just runs it once. You can see it when the value changes. And also if you just add a semicolon, it does not tell you if the value changes. Like right now it's telling it, now it's not. So the main syntax are silencing, assigning, accessing attribute through dot syntax, And then there are other keywords like if, else. So you can do node equal to if 4 greater than 5, then it's 4, else it is 90. So when you do this and you access this value, you get 90 because 4 is not greater than 5. So if statement takes logical operations, anything that takes logic in the condition and then executes either this or this based on whether that value is true or false. So for logical expression, you can use greater than, less than, equal to. You can also use in and match. For example, if I do A in ABC, it evaluates to true, but if I do this it evaluates to false. So you can use in for string and you can also use in for list. So it's evaluating tree, but if it has this, then it's false. So you could also put different data type, it's false, but if you put 1 here, it's true. And for match, it is, so you give your value and then it does match and then you provide regex. In this case, I can just do match A, which is true. But if I say ins in A, then it's false. But starting in A is true. So if you know regex, then you can basically write this like this, and then it will match. So you can use match statement for regex matching in strings. You can use in for string and list, and you can use normal operators like plus, minus, greater than, logical and, or. So you can do this and false, and false, and it will be false. So you can use logical and, or, not, etc. to change things. So other than that, yeah, there is function call. Let's go into a little bit detail. So if you want to call a function, there are environment functions that can be called anywhere. So some example, for example, of render function. So you can see the function signature at top. You can also go to the help and then look at the function that shows you what argument to use, little details, some examples, as well as the code. So it needs a template, so we provide hi, my name is name, and if we run it, it says variable name not found, so we can provide that variable here. So now it ran with this, but our name is a string, so it's showing the code. So for string, we can put this in front of a variable to make a unquoted version. So it looks like this, extra space. You can also do some transformation like upcase, downcase, and so on. And if this was a value like 2, then you would not need to do anything extra, but you can again do some transformation here, basic transformation, but of course it is a lot easier to understand if you just do that as an expression. Similarly, if I use the same function from the node context, you can see the signature is different. Here it was taking key value pair name equal to something, but if I try to run the same thing here, I will get error saying variable name not found, because this function no longer takes the key value pair and it takes this name from each of the node. So right now we have name variable empty. So if I give this variable as something, now it will render it like this. So basically in case of nodes, it takes the node attribute in the template instead of externally. But if you want to call render function in a context of node, maybe you want to pass it for something else, you can wanna do node something equals to render. Like if you wanna do this, right now it rendered because the name is available, but if you do this, so if you wanna call the environment version of the same function, you can just do this and it will run it successfully. Now it assigned all of them with this parameter instead of default parameter that we got from here. So you can chain functions, you can do let's in a different function. Okay, let's say so we can just run an environment function. So here we can chain function saying sum of 1 2 3, it's at 6. You can also chain this further saying sum of order of all the nodes, which is 8. So when you do this, it takes an array of everything and outputs that. You can access like how you would normally do node.order. Nodes is a special syntax. So here, so it basically loads the order of all the nodes in the network as a single value. Similarly, you can also use inputs to get the single value for all the inputs of the current node. So for example here, D has input of C and B, so it's getting order of 2 and 1. If we do name, so D has B and C, and B has A, C and A has nothing. You can similarly do output.name, but it errors out because D doesn't have output. So for that you might have to go conditional route where it skips D because it doesn't have output. So this special syntax basically is a conditional that evaluates whether something is true or not. So if a variable doesn't exist, it evaluates to false. If it exists, it evaluates to true. So you can use that special syntax with a dummy variable. That underscore is always true, so it's false in D because it doesn't have output. So you can also use it for other place. For example, we had a name variable for each one of them, but we don't have name2 variable. Suppose if I only made name2 variable for these two, now when I access name2, it gives me attribute not found. But if I do underscore question mark, then it gives me false for two of them and true for two of them. So if I directly access it, it will show none, because the whole point of this is only to access data. But this is a little bit different syntax. What it's trying to do is it's trying to evaluate this in the as an expression, because we are supposed to be using this in a function or something. So in these cases, when this value is none, these functions evaluate like there will be error. So when something is there, not directly accessed in an expression, then it cannot do anything. So if I do this, it says attribute not found. But if I say okay, run it only for those with name 2 in it, then it will only run for B and A, and then show that. So that should be the overall simple syntax. There are if statement, while statement. Okay, there was this thing. So basically, like node functions can be run like this. You can also give it different orders. So here it was running sequentially, now it's running inversely. You can also choose for it to only run certain node, so it's only running 2 node. And you can also give a condition with variable or something else that further chooses which nodes to run it on. So right now it's running in inverse order only on these 2 nodes if they satisfy this condition. So basically, out of all the nodes, we already removed these 2. So from B and A, only A satisfies greater than 2 index condition, so we only get A here. So instead of simple variable, you could be running any functions here, more complicated functions, by choosing only which node to run it on. So simple example could be node if dam or something, that if you have that true or false, then you run a function saying like do dam things and then parameters here. So that way you can choose which functions to call on which node instead of all of them. But network functions will be run on just once, so you don't need to choose it. But you can choose this way, like if network name is Ohio, then run the task, any task nodes something, otherwise you don't. So you can like, okay, now it has an error. Okay, sorry, this should be equals to. So if we try to run this, it doesn't give us any error, even though this function does not exist, because since if is evaluated false here, it doesn't try this. So these statements are evaluated lazily, so if that condition is false, even if it has error, it will escape it, which is important on these cases. For example, if this evaluation took place before the condition is tested, then it would have error in this node. So you can also use conditions to escape some function calls that would normally be problematic.